Hi students, in this video we are going to see periodic properties. In the previous videos I have discussed the three periodic properties: atomic size, ionization potential and electron affinity. So in this video particularly we are going to discuss about electronegativity. What is electronegativity? How it varies across a period and down a group? What are the trends? How we can answer questions on this? So keep watching. Periodic properties are properties that gradually change or increase or decrease from left to right in a period or top to bottom in a group. Now the various periodic properties that we study in class 10 are atomic size, ionization potential, electron affinity, electronegativity, metallic and non-metallic character. Now in my previous videos I have explained about the first three: atomic size, ionization potential and electron affinity. Now in this video we will see electronegativity. What is electronegativity? How it varies across and down a group. Now see, electronegativity is the tendency, underline this term, tendency, the tendency of an atom to attract the shared pair of electrons towards itself when combined with another atom. Now in the previous properties, atomic size, ionization potential, electron affinity and all, we have seen the atom in the single state, isolated gaseous state. We were measuring parameters for a single atom. Now here the atom needs to be combined with another atom, and that also shared pair, that shows there is a covalent bond. So atoms share the electrons and the shared pair is equally shared usually between two atoms, the combining atoms, but sometimes one of the atoms gets a greater share. So all this happens because of the tendencies. Each atom has a certain amount of tendency to attract electron pair. So let's take the examples of hydrogen chloride. Hydrogen atom has one electron in its valence shell. Chlorine atom has got 7 valence electrons. We know this already. Now, one electron of chlorine and one electron of hydrogen get shared. So, there is a covalent bond. Now, chlorine has the configuration of 2, 8 and 7 and 1 is shared. So, it becomes 8. Hydrogen has configuration of 1. Now, out of these two, so we can write it as H-Cl. So, this is one dash stands for a pair of electrons shared, a covalent bond. Now, since the chlorine atom has a greater tendency to attract electron, a greater electronegativity, so it will pull the electron pair towards itself. This will develop a partial negative charge developing on chlorine and a partial positive charge on hydrogen, because hydrogen is not getting the full share of the electron pair and chlorine gets a greater share. So this is happening in hydrogen chloride. So the tendency of the atom to attract electron, that is what is electronegativity. In other words, we can say chlorine is more electronegative and hydrogen is less electronegativity. When two chlorine atoms combine, chlorine atoms have 7 electrons each of them. The next chlorine atom also has 7 electrons. Now one pair of electron is shared between them. So there is a chlorine Cl-Cl single bond. There is a single covalent bond between them. Now here the electrons are attracted equally by both the atoms. Both the atoms have same tendency to attract. So no partial charges developed. So it is shared equally. Okay. So what I am trying to say is each atom has a certain tendency to attract electron pairs towards itself. Now, this tendency is what is called electronegativity. What is electronegativity? Electronegativity is the tendency of an atom to attract the shared pair of electrons towards itself when combined with another atom. Now, let's see what are the factors that determine electronegativity. The various factors. The first factor is the atomic size and second is nuclear charge. Atomic size, when the size of the atom increases, when atomic size increases, the tendency to attract electron weakens because the outermost orbit is far away, so the electronegativity decreases. The nuclear charge increases, the atom is able to pull electron pair towards itself strongly. In other words, electronegativity increases. So these are the parameters that we will apply now across a period and down a group. Atomic size increases, electronegativity decreases. Nuclear charge increases, electronegativity increases. So let's see this across a period. How this varies across a period. Across a period we have the atom lithium. The configuration is 2, 1, atomic number 3, 4, 5, 6, 7, 8, 9 and 10. So the configuration is 2, 8, 2, 9, 2, 6, 2, 5, 2, 4, 2, 3 and 2, 2. Yes, now same way in this third period we have sodium 281, 282 for magnesium, 283 on aluminium, 2, 8 and 4 on silicon, 2, 8 and 5 on phosphorus, 2, 8 and 6 on sulfur, 2, 8 and 7 on chlorine, 2, 8 and 8 on argon. We are familiar with this configuration. This is atomic number 11, 12, 13, 14. Just add up the configuration, you get the number. 285 is 15 and 16, 17 and 18. So these have octets, complete octet, right? So across the period, what do we see? The nuclear charge is increasing, 3, 4, 5, 6, nuclear charge increases. Okay. And what about the atomic size? In the first video we have discussed about it. Atomic size across a period decreases. Atomic size decreases across. Okay. So let us apply this and see how the electronegativity is affected by these properties. So atomic size across is decreasing and nuclear charge is increasing. That's what we have seen. And previously we have seen when atomic size increases, electronegativity decreases. So when atomic size decreases, the outermost orbit is coming close to the nucleus. So the electronegativity increases. And nuclear charge increases, again electronegativity increases. So when we combine these factors, the resultant effect is an increase in electronegativity across a period. So what is the conclusion we get from here? Electronegativity increases across a period. Right? So let us write the elements of the third period, that is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Now argon being noble gas, it has no tendency to attract electrons, so we will leave it out from the comparison. So from sodium to chlorine, the most electronegative is chlorine and the least electronegative is sodium. In other words, alkali metals are the least electronegative. And halogens, group 17, halogens are the most electronegative. Okay, so the electronegativity increases gradually. So if you want to arrange them in the increasing order, write from the left to right order. In the decreasing order of electronegativity, write from right to left. Okay, so that's about across a period. Now let's see down a group what happens. Down a group, let's take there are three groups shown here. Any one group you can take. Group 1 is hydrogen 1. Configuration is this one is 2, 1, 2, 8, 1, 2, 8, 8, 1, 2, 8, 18, 8 and 1. Then cesium 55, 2, 8, 18, 18, 8 and 1. And francium 2, 8, 18, 32, 18, 8 and 1. So this is it. Now we have seen already that down a group, as the orbits are increasing, atomic size increases. This we have seen, also discussed in the previous video. And the nuclear charge 1, 3, 11, 19, nuclear charge also is increasing. Nuclear charge increases. Okay, atomic size increases, nuclear charge increases, both are increasing down. So what will be the effect of this in the electronegativity? Okay, atomic size is increasing, nuclear charge is increasing. Now what will be the effect? We have seen atomic size increases, electronegativity decreases. This is what we have seen previously. And nuclear charge increases, electronegativity increases, we have seen. We also know that the first one is a strong factor and this is a weak factor. So the strong factor dominates. So the net effect is a decrease in the electronegativity down a group. So the most electronegative will be always on top and least will be down. So if you take the halogens, fluorine, chlorine, bromine, and iodine and all, so this will be the least electronegative and this chlorine will be the most electronegative. So what is the conclusion we have here? The conclusion is electronegativity decreases down a group. So the summary of what we studied in this video is electronegativity increases across a period and decreases down a group. So I hope you understood this, children. Now you can go through this video once again if you want to understand things better, and you may write your questions in comment, and please like and subscribe the channel so that you will see the next video. In the next video we will be discussing about metallic and non-metallic characters. Thank you.